Hello everyone, I am Vidhi, a geek like you here at GeekyAnts. Recently, I have been working on the GlueStack ecosystem, and previously, I have worked on many dev tools. And this talk is about the things that I have learned while implementing the major features in those tools. So, that is shared control, real time update of multiple users in one single page. So, let's find out. Before directly diving into sockets, we will discuss traditional techniques used for creating real-time applications, their drawbacks, and how web sockets help us. So we will first discuss how does HTTP works. HTTP Hypertext Transfer Protocol is widely adopted for transmitting data over the internet. It works on the TCP protocol, that is the Transmission Control Protocol. For those who don't have much idea about TCP protocol, it breaks our message into small bundles and then reassemble on the opposite side, which help us to maintain efficiency instead of sending everything in one go. So this is how HTTP works. We have a client and a server. A client sends an HTTP request to the server, and the server responds with the HTTP response containing the requested data. Each request is independent of each other, and we can constantly ask the server if there are new messages in order to receive them. And once the message is received on the client side, the connection is closed, and we have to create a new connection each time we make a request. So, before the introduction of WebSockets, there were different techniques like polling and long polling, which were used to create real-time applications. We will discuss in brief about what they are. So first we will discuss the HTTP polling. So in this case also, in HTTP polling, the client requests the data from the server. If the data is available at the server, it sends back the data to the client. And then client waits for some time. We can change the time limit. And after some time, it establishes the connection again, and again with the server, and again clients request the data from the server. If the data is not available from the server side, it closes the connection and then tries again after some time. As we can see in this diagram, client makes first request. If the resource is available from the server side, it is sent back. After some time, second request is made. Even if the resource is not available on the server side, no response is sent and the connection is closed. After some time, it again tries to establish a connection and get the data. So this increases the latency because we need to make connection again and again. It increases network traffic, increases the server load, and it is unidirectional as only client can make request to the server, not vice versa. Solution to this was long polling. So how does that work? In long polling, client sends a request and waits for the server to respond. The connection is kept open until the server sends a response. Once the response is received, the connection is closed. So when the client makes the first request, it waits for the server to get some data, and then it sends the response. And then the second request is made. Advantages of using long polling over polling is that it does not make frequent requests to the server, minimizes network traffic. It also increases responsiveness because if the data is available on the server side, it will immediately send the data to the client and it will be rendered and whatever operations can be done, which enhances the real-time experience for the user. But if we scale our application, this will increase the server load again because there will be multiple requests from multiple clients waiting for the response from the server. It is also unidirectional because only client can make the request. Server can't send data until and unless client makes a request. It also degrades the user experience because user has to wait for the server to get response. Keeping these issues in mind, WebSockets came into picture. So WebSockets are basically an advanced API that provides two-way communication, that is bidirectional communication between the server and the client. In other words, it provides consistent connection between the client and the server, and both of them can start transmitting data at any time. So, like we see in the diagram, we just need to establish the connection once. Once that is done, any messages can be sent from the server to the client and vice versa. It is bidirectional in nature, which makes it faster protocol. It also uses TCP protocol only, but this it is much faster. So where can we use WebSockets? WebSockets are enable bidirectional communication, allowing both server and client to send data at the same time, which is useful when we need frequent updates. It also provides low latency requirements, that is compared to HTTP, because the overhead of establishing a new connection every time is eliminated. And WebSockets are useful for creating real-time application where the data to the client side changes frequently, and the server needs to push the data to the client and maintain a persistent connection. Some of the examples would be chat app, multiplayer games, and etc. But using sockets is also not a good idea in case we are building CMS, content management system, or similar applications, because for that we have HTTP request, and using get, post, put, and delete in that case would be a good idea. So in the end, it narrows down to the requirement of the project, considering factors such as real-time needs, data flows, latency requirements, and the nature of the communication to determine which protocol is most appropriate. So now we will discuss how does WebSocket work. So I have booted an Express server which is running on localhost 3003, and I have rendered a very basic form using the /route. I have sent the HTML file. So in server.js file, I have created a WebSocket server on port number 3004. So it is a new WebSocket server created on the port 3004. Here we can send other config also, like what protocol we want to follow and etc. WebSockets basically provides different events that we can attach to it. So just to know, this message event we attach to the server, and whenever the message is received, this event will be triggered. Similarly, we have a close event. When the socket connection is closed, this event will be triggered. So similarly, we have different events present on the front client side as well. Here we have created a new socket using the WebSocket API from the client side, and we are connecting the socket server to the localhost 3004, which was what we created here. This was the server that we created, and from the client side we are trying to connect to that server. And it also provides different events like open, message, on close, and other events as well. So these events help to make we attach these events to the socket, and we can do whatever operation that we want, and we can also send the data from here and receive it. So here I have rendered a basic form here, and on manipulation, submission of that form. One more thing, socket also provides different methods that we can use, like socket.send. This will emit an event which will be received on the server side here at server.onMessage, and from the server side we will also send an message which will be received on the event socket.add event listener message on the front end side. So this way communication can happen between the server and the client. So I'll try to run this basic example here. One second. So whenever I try to write some message in the form and click on the send button, this message is rendered from the server side. This message was sent using socket.send command here from the event listener that was attached to the form, and on the server side it was received here on the event listener message received, and then we are maintaining an array messages where we are pushing the messages that we are receiving, and then we are returning the entire messages to the client which are received in this event listener, and then we are rendering that using a unordered list. So in case I try to write something new, it will return the entire array which will be rendered on the front end. So the WebSocket provides different methods like close, send, etc. that we are using here, and it also provide a different schema, that is the WS. We can use HTTP here as well, but WebSocket provides the schema that is specifically to WebSockets to send data. We can also use WSS similarly like HTTP and HTTPS. So that is the basic work. So from the server, we receive socket.send, client sends a message using socket.send to the server, which is received on the message event of the server, which further sends the message to the client, which is then rendered on the screen. So this is the basic working. Everything in this app was implemented using the very low API provided by the web. But there are many other different library that provides functionality and uses these under the hood. So till now we have looked in the low level API provided by the WebSockets, but there are many libraries that provide high level APIs with some extra functionality, but under the hood they also uses the APIs provided by the WebDocs. Few of those libraries would be Async API, Socket.io, HumbleNet. Async API use event-driven architecture. Most of these use event-driven architecture. So we have used Socket.io, which is widely adopted in the web community, in one of our projects where we used to share a project with different users, and changes done by one user can be seen by the other user in the real time. So yeah, this is the basic implementation of that. Here, if I try to change the secondary color, changes will be reflected in my app, but this similar app is shared with someone else, and they can also see these changes, and the changes done by them are reflected back in my application as well. So this was the basic use case where we used sockets in the real-time applications, and they were very useful and made the development very faster. Yeah. Thank you for your attention, and I hope this presentation has provided you some insights on how socket work and how they can help you in building your real-time applications.